Our world, for instance, is the Milky Way galaxy, and the closest galaxy to us is the Andromeda Galaxy. We think there are around 100 billion galaxies in the observable universe. The Andromeda Galaxy has been instrumental in reshaping our comprehension of the universe and our place inside it. For example, while our galaxy is the Milky Way, the closest one to us is Andromeda. We estimate there are around 100 billion galaxies in the observable universe. This revelation gave undeniable proof that the universe and the concept of creation do not revolve around Earth. It broke the idea that the Milky Way was the sole galaxy in existence, proposing that we're simply a minuscule piece of the vast universe. Our information about Andromeda has grown over the last century, principally through observations made on Earth. However, with advanced tools like the James Webb Space Telescope, JWST, now available to us, our perspective has drastically changed. Surprisingly, recent information from the JWST has challenged our past thoughts about the Andromeda Galaxy, presenting another astronomical riddle to solve. The JWST has detected unusual signals from our neighboring galaxy, leaving the academic community astounded. Join us as we explore how the JWST captured a disturbing signal from the Andromeda Galaxy. The perception of the Milky Way has evolved significantly throughout human history, shaped by our developing understanding of the universe. Before, when our technological abilities were limited, the Milky Way appeared as a hazy band of light across the night sky, inspiring various interpretations and mythologies. It was often viewed as a mystical and central element in the cosmological beliefs of different cultures. In the 1920s, American astronomer Edwin Hubble made a groundbreaking discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. Through observations and analysis, Hubble demonstrated that distant clouds beyond the Milky Way were actually separate galaxies, each containing billions of stars. One of the closest of these galaxies was the Andromeda Galaxy, also known as M31. Andromeda has a rich history of observations dating back centuries. One of the earliest known records of this celestial object can be traced back to the 10th century when Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud in star charts from that period. The significance of these observations lies in the fact that al-Sufi could identify this distant cosmic entity without the aid of telescopic instruments, relying solely on his sharp vision and observations. Later, in 1612, a more detailed description of the Andromeda Galaxy based on telescopic observations was provided by Simon Marius. His work laid the foundation for future astronomers to study this massive cosmic structure. In 1764, the renowned French astronomer Charles Messier classified the Andromeda Galaxy as M31 in his famous Messier catalogue, mistakenly attributing its discovery to Simon Marius, unaware of al-Sufi's earlier work. Nonetheless, Messier played a significant role in putting Andromeda on the map. For almost a century after this, astronomers worldwide were trying to learn more about this mysterious galaxy, each building upon the findings of the last. Before that, Italian astronomer Galileo Galilei indeed revolutionized our understanding of the Milky Way in the early 17th century. Using his newly developed telescope, he made significant observations that challenged the prevailing Aristotelian cosmology. He discovered that the Milky Way was not just a diffuse band of light but a vast collection of individual stars, planets, and other celestial objects. Through his observations, he showed that the Milky Way was not at the center of the universe as previously believed, but rather a massive expanse of stars scattered throughout space. In 1750, English astronomer Thomas Wright proposed a new hypothesis in his work, an original theory or new hypothesis of the universe. According to Wright's theory, the Milky Way was not a random distribution of stars in space but a completely flat layer of stars. He also suggested that part of this vast structure was our own solar system. While Wright's theory was a step forward in understanding the structure of the Milky Way, it was still limited by the observational technology available at that time. They all still believed that the Milky Way was all there was, and considering the limitations, that's not surprising. A significant leap in understanding the nature of the Andromeda Galaxy occurred in 1864, when English astronomer William Huggins made a noteworthy observation. He studied the spectrum of Andromeda and noted that it was different from that of a typical gaseous nebula. This paved the way for the galaxy to truly be recognized for what it is. Andromeda has a mass estimated to be between 1 and 2 trillion times that of our Sun. It's an epic cosmic structure that happens to reside relatively close to us in the vastness of space. Based on all the research conducted so far, scientists believe that Andromeda is around 10 billion years old, making it very ancient in astronomical terms. Its age suggests a long and complex history of formation and evolution. One of the fascinating aspects of Andromeda's origin is the hypothesis that it formed through the merging of several small proto-galaxies. This suggests that over billions of years, smaller cosmic entities gradually came together under the force of gravity to form the magnificent Andromeda Galaxy we see today. Such cosmic mergers are common occurrences in the universe, shaping the formation and structure of galaxies. For a long time, astronomers thought Andromeda was significantly more massive than our own Milky Way galaxy. From an observational standpoint, a mistake like this could easily be made because we are within our own galaxy, and observing Andromeda from Earth makes it look so large that you'd easily think there's no way anything could come close to its size. However, that is not the case. Galaxies are vast systems, and their mass is intricately related to the distribution and movements of stars, gas, dust, and dark matter within them. Pinpointing these values accurately is a demanding task that requires sophisticated observational techniques and meticulous analysis. This could not have possibly been done during the 1700s or even in the 1800s. This kind of information requires modern instruments, which is why it is only coming to light now. Recent research has led to a reassessment of these beliefs. New findings have led scientists to slightly decrease their estimate of Andromeda's mass while simultaneously increasing the mass attributed to our Milky Way. As a result, the current understanding is that the masses of these two cosmic giants are much closer than previously thought. If you were to be in Andromeda and looked at Earth, you'd see an equally massive galaxy. This puts into perspective how vast it is, known to extend farther than our own Milky Way. With an impressive diameter of around 220,000 light-years, Andromeda surpasses the Milky Way's estimated diameter of roughly 100,000 to 175,000 light-years, making it a genuinely enormous cosmic entity spanning a vast region in space. This revised perspective also highlights the complexities and challenges of accurately measuring the mass of galaxies. In the core of the Andromeda Galaxy, a supermassive black hole exerts a tremendous gravitational pull on surrounding stars. As these stars orbit the black hole, they follow elliptical paths, similar to planets orbiting the Sun in our solar system. At a certain point in their elliptical orbits, stars come closest to the black hole, known as the perihelion. At the perihelion, gravitational forces are at their strongest, causing the stars to move at their highest speeds. This is when the stars cluster together and become more concentrated in space around the black hole. As they cluster, the stars emit energy as radiation, including visible light and other types of electromagnetic radiation. The increased concentration of stars and the release of radiation create the brighter point of concentration that astronomers observe in the galactic center of Andromeda's active galactic nucleus, AGN. An active galactic nucleus, commonly known as an AGN, is a highly energetic region at the center of a galaxy. It is characterized by intense emissions across various wavelengths, from radio waves to X-rays. AGNs are powered by the presence of a supermassive black hole at the heart of the galaxy. These supermassive black holes are incredibly dense regions in space where a tremendous amount of mass is concentrated within a tiny volume. When astronomers observe active galactic nuclei using advanced telescopes like the Hubble Space Telescope, they observe a fascinating phenomenon. One of the most intriguing features of the Andromeda Galaxy is its AGN, which appears to have 2 points of central focus. There are 2 distinct regions where light and other forms of radiation are emitted more intensely than in the surrounding areas. The second point of focus is just slightly off the true galactic center. Within this region lies the supermassive black hole. The mass of this black hole has been estimated to be between 1.1 to 2.3 times 10 to the power of 8 solar masses, meaning it weighs around 110 to 230 million times as much as our Sun. Supermassive black holes are believed to be common in the centers of galaxies, including our own Milky Way. As a result, they play a crucial role in the evolution and dynamics of galaxies. When matter, such as gas and stars, gets too close to a supermassive black hole, it forms an accretion disk around it. This disk of swirling material heats up and emits intense radiation across various wavelengths, which is why the AGN is highly luminous. When astronomers observe the active galactic nucleus of the Andromeda Galaxy, they notice a brighter point of concentration near the central supermassive black hole. This prominent feature is a result of the unique gravitational interactions between the black hole and the stars in its vicinity. The Andromeda Galaxy also has another fascinating feature: an abundance of globular clusters. These globular